This video is to investigate task number 17. In task number 17, it begins with a definition that in three space, two lines that are perpendicular to the same plane must be parallel. Before we go on to investigate task, I just want to look at that definition. So I am looking at a cube because it is a fairly simple way to look at this definition. My cube is purple. The face is orange that I want to reference. Now the face that's orange is going to be serving as my plane. And what this stated was that two lines that are perpendicular to the same plane. So as we can see, the top line that is red is perpendicular to the plane because I have put in the 90 degrees to show that that is in fact perpendicular. And then the blue line is also perpendicular to that orange plane. And as we can see, this is going to hold true regardless of the perception that you have in three space. So that is where we're starting. But then in task number 17, it asks to look at if you have two lines that are perpendicular to a third, they don't have to be parallel, and try to explain why. So I'm going to go ahead and get rid of the lines that I have here and also the angles that I have so that it doesn't become confusing. And I'm going to go ahead and add in some new lines. So let's see, I can't remember which ones I want to use, so just will take a second. I want to use, I want to use that line, and I want to use, not this one, not that one, nope, sorry about this, nope, I know I have it. Sorry for the hold up here. Alright, I'll just redraw it. The line that I want to use is this line right here. I can't find it, but okay. Let's look at this before we go further. So it asks us to take two lines, and with those two lines, they wanted those two lines to be perpendicular to a third. Before we add in that third, I do want to point something out. What these two lines are doing is showing us skew lines. So the whole point of why this is going to be able to work where two lines are perpendicular to the third line but not creating parallel lines is going to be because of the skew formation. So what we are going to continue with now is to show that they're perpendicular to a third. So I'm going to go ahead and make a third line. And I'm going to make this try to stand out, so we're going to use an orange and a pretty thick line too, just to make this stand out. So we are doing this point to this point. That's going to be our third line. Now, in order for us to be able to prove the whole scenario though, this blue line needs to be perpendicular to the orange. So I'm going to go ahead and show a 90-degree angle. And then this red line has to also be perpendicular to the orange. And it is. So I've got both being perpendicular, and so that idea matches, but what's even more interesting is that they are truly creating skew lines. And again, we're not looking at the orange line as the skew, we're looking at the red and the blue as the skew. That orange line is just the connection between the two if we wanted to connect them. So that allows it to be the perpendicular. But instead of ending up as parallel, we are going to be able to see that they are going to be skew lines instead. Again, we are looking at the blue line and the red line. And what I'm going to do just to make this even more easy to see is take that away. I'm going to rotate this up. And I think what's important to note here is that parallel lines can be coplanar, whereas skew lines cannot. And this is showing why it ends up being skew, because both of the lines are not going to share a plane with each other. They're definitely perpendicular to a shared line, but that doesn't mean that they're sharing a plane. So because they're non-coplanar, non-intersecting, and non-parallel, they're going to be skew. So 17 is really asking us to investigate further the idea of skew lines.